Hello guys, welcome back to the YouTube channel. In this video, we're going to discuss arrays problem number 7 in must do coding questions, which is number of pairs. If you are new to the channel, please like and subscribe to the channel and click on the bell icon. So today's problem is number of pairs. So it is a pretty straightforward problem. Number of pairs given two positive integer arrays ARR and BRR. Find the number of pairs such that x power y is greater than y power x. So here we will be having two arrays named ARR and BRR. Let's take this example number 1. ARR consists of 2, 1, 6 and BRR consists of 1 and 5. So here we need to find a pair such that x power y is greater than y power x. So in this case, like, what will be the pairs? The pairs will be 2, 1, 2, 5, 1, 1, 1, 5, 6, 1 and 6, 5. So in this number of pairs, there are only 3 pairs such that x power y is greater than y power x. So like, let's take this pair 2 and 1. So 2 power 1 is greater than 1 power 2. So this is one pair. And 2 and 5 here also. 2 power 5 is greater than 5 power 2. So this is one more pair. And 6 and 1. So this is third pair. So basically, in these two arrays, we need to find a pair x comma y so that x power y is greater than y power x. So what is the expected time complexity? It is big O of m plus n. Yeah. So basically here what we will be getting two arrays. Let's take the two arrays. Let's take this is ARR and this is BRR. And an element in ARR is called, let's take x, and BRR it is y. So now what exactly we need to do? We need to find the pairs. Like, what are the pairs? X comma y is a pair such that x power y is greater than y power x. So this is our final outcome. We need to find a pairs. That's it. So what is the brute force approach to solve the problem? By iterating within the two arrays and every time calculating the x power y and y power x and checking whether it is a greater or not. So basically here when you are iterating, iterating is okay, big of length of array of ARR into length of array of BRR will be the time complexity, and like computation also, like it takes more computation. So whenever the values of the integers in ARR, if it is 30 or 20, so the computation like 30 power 40, so it is very high computation. So that's why that is not recommended. So basically, how to solve this problem? So yeah, in mathematical observation, we can assume one thing, like we can tell one thing, like if y is greater than x, then x power y is greater than y power x. So this is a mathematical observation. So basically, whenever y is greater than x, then obviously x power y is greater than y power x, but with some exceptions. We will see that exceptions after. So let's take an example. Let's take x equal to 3, y equal to 5. So obviously 3 power 5 is greater than 5 power 3. So what is 3 power 5? 3 power 5 is 243. Is greater than 125. Obviously this is correct. So in most of the cases, whenever y is greater than x, x power y is greater than y power x. But there are some exceptions. We will see about that exceptions now. So basically the exceptions comes like in the values of 0 and 1 only. So if we handle the exceptions correctly, we can easily solve the problem. So before that, what exactly is an exception? See, what is our observation, mathematical observation? We have assumed that whenever y is greater than x, then what we can tell? We can tell x power y is greater than y power x. Or else you can tell in one more way. Whenever x power y is greater than y power x, y is greater than x. So this is our mathematical observation. But here, what is an exception? Exception in the sense, even though my y is greater than x, this is false. Like even though if my y is greater than x, x power y is not greater than y power x. Or else one more thing you can tell, my x power y is greater than y power x, but y is not greater than x. So if this is true and this is not true and this is true, this is not true. So that is an exception. So basically the exceptions will be coming in the values of 0 and 1 only mostly. So we will calculate the values 0, 1 with respect to of x and y, and after that the same approach we have followed, right, to calculate the number of pairs. Whenever y is greater than x, obviously x power y is greater than y power x. So in that way we will do. So okay, we will take first exception. There are basically 4 exceptions, that's it, we need to handle. So first exception is whenever x equal to 0. See, whenever x equal to 0, there is no pair forming x comma y so that x power y is greater than y power x. Why? Because see, whenever x equal to 0, what happens if we substitute x in the formula x power y is greater than y power x? What happens? 0 power y is greater than y power 0. What this will happen? 0 power anything is 0 is greater than anything power 0 is 1. So no matter what value of y you take, so this can't be true, right? So basically, whenever the x value is 0, one thing you can state, that is 0 pairs are formed. That's it, very simple. So 0 pairs are formed of x comma y so that x power y is greater than y power x. That's it, very simple, straightforward. So after that we will see the second exception, which is x equal to 1. So whenever x equal to 1, we will be having only one pair. That's it. That one pair is only 1 comma 0. So whenever the x value is 1, we will get only one pair. So other than this, no matter what value y you substitute in this formula, you will not get. Okay, let's substitute x equal to 1 in this formula. So what happens? 1 power y is greater than y power 1. So what is this? 1 power anything is 1 is greater than y. So here 1 is greater than y. So when this condition will be true? This condition will be true if and only if you substitute 0 in place of y. Other than 0, if you substitute any number like 2, 3, 4, 5, 6, this condition is false. So by taking this, one thing I can tell, whenever x equal to 1, only y equal to 0 forms a pair such that x power y is greater than y power x. So that means one thing I can tell, whenever x equal to 1, number of zeros in BRR forms pair. So basically what is that pair? That pair is 1 comma 0. Apart from 1 comma 0, no other combination of x comma y satisfies this condition, x power y is greater than y power x. So let's take one more condition, 3. So we have seen for x equal to 0 and x equal to 1, right? So now whenever x is greater than 1, then y equal to 0 comma y equal to 1 also forms a pair such that x power y is greater than y power x. So okay, let's take one condition. Whenever x equal to 6 and y equal to 0, x equal to 6 and y equal to 1. So what happens here? So 6 power 0 is greater than 0 power 6. 6 power 1 is greater than 1 power 6. So obviously anything power 0 is 1 is greater than 0 power anything is 0. Here 6 is greater than 1. So this is condition, this is true, this is true. See, whenever x is greater than 1, so y values which are greater than x is okay. But whenever x is greater than 1, y equal to 0 and y equal to 1 also forms the pair. So by this, one thing I can tell, whenever x is greater than 1, number of zeros comma ones in BRR forms pair. So this is basically three main important exceptions. So apart from that, only one small exceptions, that is, those are 2 comma 3, 2 comma 4, 3 comma 2. So these three are some special pairs, important special pairs. Even though see 2 cube 3 square, 2 power 4 is greater than 4 square, 3 square is greater than 2 cube. So in this case, if you see here, 8 is greater than 9. No, see here x is greater than 1 and y is greater than x, but still this condition is false. Here also the same thing, 16 is greater than 16. Here also the same thing, x is greater than 1 and y is greater than x, but this condition is false. Here the third case is different. Even though here x is greater than 1 and y is less than x, but still this condition is true. 9 is greater than 8. So we just need to minus these two pairs and add this pair, that's it. So basically, to solve this problem, we have taken one mathematical observation, that is, whenever y is greater than x, obviously x power y is greater than y power x, but with 4 exceptions. In that, basically the exceptions are 0 comma 1 only. We need to handle it separately. Whenever x equal to 0, there is no pair, and whenever x equal to 1, only 1 comma 0 is the pair. So whenever x equal to 3, the normal condition is okay, but even though my y equal to 0 comma 1 or less than x, but forms the pair, so that we need to handle separately. And these three are special cases, 2 comma 3, 3 comma 4 and 3 comma 2. In these cases also the same thing. If first two cases doesn't satisfy and the third case satisfies, so we need to minus this and add that. So very simple. So basically how we will solve this problem is, so we will be following a 2-pointer approach. There are two arrays, right? ERR and BRR. So basically, let's assume this is an x and one pointer is pointing to two pointers I comma j are pointing to the starting of the array. Now, what is the mathematical observation which we have seen? Whenever y is greater than x, x power y is greater than y power x. So basically what we wanted this many number of pairs. We need to pair so that x power y is greater than y power x. Now, what we will do to solve this problem is, first we will sort the arrays. So these two are sorted. Sorted in the sense it is in the ascending order. So from here to here it is ascending order. So first we will iterate through the x. That means ARR. So we will iterate in the ARR and every time we will find a y so that y is greater than my x. So this is our condition, right? So we will find a y in the BRR that satisfies this condition, y is greater than x. Up to then we will iterate my j pointer. So first I will fix my I, after that I will iterate my j pointer. So this BRR is sorted. That means it will be small, big. It is small number to big number. So my j pointer will be traversing to the right side and it will find a y so that my y value is greater than the x value. Now from here at this particular frame, I can tell this x comma y is a pair. And one more thing also I can tell. This is sorted array, BRR is sorted with the x value. If y satisfies, obviously the right side elements of the y are greater than y. So example, this is y1, this is y2. So obviously y2 is greater than y1. Then what I can tell, x comma y2 will also form the pair and x comma y3 will also form the pair and so on. So all the elements right side to the y will form a pair with the x. Why? Because all the elements right to this pointer pointing to the j are greater than the x. That means every thing will be forming a pair. So how to get this many number of pairs? Okay, let's take an example. This array of ARR length is n and this BRR array length is m. So how to get this many number of pairs? So in this length I need to just minus the j, that's it. So every time what I can tell, for every x value, find a jth position so that my jth position value y is greater than ith position x. So after finding that, one thing I can tell, what all the elements right side to the y is greater than the y1. So everything will form a pair. That means how to get that number of pairs? We can get by just subtracting my m with j. That's it. So in these two arrays, every time I will take 2 pointers. For every pointer, I will iterate this I, this j, and I will get to a place where x is greater than y. So in this case, what I can assure that all the elements right side to my y are greater than y. So every element will form a pair with x. So what I can tell? I can tell that if this count is m and this index is j, so for this particular element x, there are m minus j pairs forming. And one more thing, see, after this x, this is also sorted. So this is also sorted. So after that, I will increment my pointer, and there is x2 example here. So for x2 also, this all elements left side to the y will not form the pair. Why? Because x2 is greater than my x1. Then I can't find any value which is left side that should be greater than my x2. Why? Because both are in the sorted order. So what I can tell, the element y which I am finding, obviously it will be right side. So left side I can ignore. So basically in two arrays, I will iterate from here to here. So this will be just going to right side. There is no point of iterating left side. Why? Because while finding the greater number, these both are sorted arrays. So for this x1, I have find a greater number here. For x2, there is no possible value of y which is greater than on the left side. Obviously it will be on the right side. So this is the process which we follow to find the number of pairs. So let's code this. Implementation in Java. Here this function is returning an answer in integer. So for that we will initialize an answer that returns the number of pairs in ARR and BRR. So here capital X and capital Y are the two arrays. So first int, let's take answer which we're gonna return. I'm initializing that to 0. Now here we have so many exceptions here. So we have assumed that if y is greater than x power y is greater than y power x. So for that there are some exceptions. So here as you can see, whenever x equal to 1, so here how many number of pairs will form? Number of zeros in BRR. So to maintain like number of zeros and number of ones and number of twos, threes, so what I am doing is I am just creating some variables. In that I will just store number of zeros, ones, twos, threes and fours in y, so that it is easy for me in the code to just use them. So I will initialize the variables like c0 equal to 0, c1 c0 equal to 0, c1 equal to 0, c2 equal to 0, c3 equal to 0, c4 equal to 0. So basically what I will be storing here is the count of zeros, ones, twos, threes and 4 in my y array, so that it is easy for me in future code for finding the number of zeros in y, zeros in y, ones in y, twos in y. So let's initialize these all variables. Like how to find the number of zeros and ones and twos and threes and fours, just iterate a loop and check condition, and after that we can do. So for int y in the array, for int y in array y, So every time what I am checking, so if my y equal to 0, what I should do? I should increment my C0 value. That's it. If my y is if my y is 1, so else if my y double equal to 1, then what should happen? C1 should increment by 1. Else if my y value is equal to 2, then C2 should increment. Else if my y is double equal to 3, C3. Else if my double y is equal to 4, then my C4 should increment by 1. So that's it. So what this for loop will do, this for loop will just iterate in the capital Y array, and every time it will check whether my current element Y is equal to 0, 1, 2, 3 or not. So if it is 0, then it will increment my C0. If it is 1, it will increment my C1. 2 means C2, 3 means C3, 4 means C4. So it is very simple. And one more thing, here to solve the problem, we are assumed that these two are sorted, right? Arrays. So for that, we will sort the two arrays. So I'm using arrays.sort function. Arrays.sort of capital X arrays.sort of capital Y. Now I'm initialized C0, C1, C2, C3, C4, and my two arrays are sorted. So, and I will take one more two variables m and n to to store the length of x and y. Int m equal to x dot length and int n equal to y dot length. Very simple. After that, I will initialize two pointers I and j, and I will iterate I, and I will iterate like by keeping I as constant, I will iterate in the j and find the jth index so that my small y is greater than my small x. And after that, all the pairs will be formed which are from y to right side of the y in the capital Y. So it is very simple. So first I will initialize my jth pointer, int j equal to 0. Now iterate from the x array. That means int I equal to 0, I less than the length of x, that is m, I plus plus. So here basically first I will handle the exceptions. After that we will go through the actual loop. So what exceptions we have here? X equal to 0, x equal to 1, like x is greater than 1, and these small three exceptions. So first we will handle that exceptions. So what is the first exception? If my x equal to 0. So if capital X of I equal to 0. So whenever my small x equal to 0, then there is no pairs formed, right? So I can just continue. So nothing to do anything here. What is my second exceptions? My second exception is small x equal to 1. So whenever my small x equal to 1, so here what I have told, whenever my small x is equal to 1, number of zeros in BRR forms the pair. So that's it. Here I just need to add number of zeros in 5. So here we have calculated number of zeros in y, right? So basically we need to just add answer plus equal to number of zeros in y is C0. That's it. So what is the third exception? My third exception is whenever x is greater than 1. So I can just write else case here. So what is the else case? Obviously else case is x is greater than 1. So here also whenever my x is greater than 1, one thing I can tell, number of zeros and ones forms the pair. So number of zeros and ones in the y, I have calculated C1 and C0 and C1. So I just need to add them, plus equal to C0, C1. And after that, the third exception also is completed. So my fourth exception is this small. When x equal to 2, these 3 and 4 will not form the pair. So I need to minus them. And when x equal to 3, when y equal to 2 will form the pair. So we need to add. So very basic. So what I need to check, if my x of I so what happens if when my x of I is equal to 2, I need to just minus the count of 3s and 4s in y. So that's it. Answer minus equal to C3. Answer minus equal to C4. So why I'm doing minus? Here, as you can see, even my x equal to 2, 3 comma 4, even though the condition satisfies, it not forms the pair. So that's it. That's why I'm just minusing it. So one more case is also there. Else if, what is that case? Whenever my x of I is equal to 3, even though here the condition is false, it is forming a pair. So that's why I need to add. Plus equal to C2. Why? Because whenever x equal to 3, number of y's, sorry, number of 2's in the y will form the pair. That's why I'm just adding this. So here I just handled my 4 exceptions. That's it. Now here comes the main thing. Keeping I as constant, I should iterate the j in the second array and go at a point so that my y is greater than x. So for that I will just write a simple while loop. While, so up to what end the while loop can go? My j pointer, it is less than n in the sense the size of the array. And so what condition I need to get? I need to get the condition small y is greater than small x. So very simple. So small y is less than or equal to capital X of I. So if this is the case, I need to just increment my jth index. That's it. This is the condition, like if small y is less than or equal to small x, just increment. So up to the while loop is completed, my j pointer will be going to some location, like here it came. Now, so how to get the number of pairs? So just by subtracting the total length with this index, we will get the number of pairs. So here what I can write? I can write answer plus equal to, what are the number of pairs? N minus j. Here n is the length of the array. I am just minusing the jth index. Where is the jth index will be? Jth index will be at a place where my small y is greater than my small x. That's it. So this is exactly what we wanted, right? So after this for loop entirely executed, I will added all the pairs in answer variable. So obviously answer variable has the answer. So I need to just return. Return answer. Okay, semicolon. Okay, some semicolons I need to give, sorry. Okay, I think new bracket came. For condition checking, we need to use double equal to. That's why here. Yeah. So if I submit, yeah, all cases are passed. So basically here we will be handling the first exceptions, and after that we will take the while loop, we'll increment the jth pointer and we will get the answer and we will return it. So very simple.